Hello and welcome to this lecture on compiler design. Today we will be discussing the questions on GATE 2023 or the questions asked in compiler design in that subject, in the GATE 2023 exam, right? So let's begin without any further delay. But before that, we'll quickly discuss the question distribution, right? So the question distribution was there were only four questions asked in this exam regarding compiler design. One mark question and three 2 mark questions, right? So total were 7 marks were asked from this topic. Okay. So let's dive into the first question here. The first question is says that it talks about the phases of the compilation process. Consider the following statements regarding the front end and back end of a compiler. Statement 1 S1 is the front end includes phases that are independent of the target hardware. Statement 2 is the back end includes phases that are specific to the target hardware. And statement 3 is the back end includes phases that are specific to the programming language used in the source code. So to understand the solution to this question, you will have to first look at your typical phases of analysis, right? So you are given a C code, let's say it's a C program. Okay. You pass it through something we call a preprocessor. Okay. Now preprocessor, if you don't remember, preprocessor does macro expansion and header file inclusion. After that, you go into something called lexical analysis. Right? Then from there it goes to something we call syntax analysis. And what does lexical analysis do in one line? Lexical analysis read the source program line by line, character by character, and divides the entire program into a sequence of tokens. These sequence of tokens are fed into the syntax analysis, which creates something we call a parse tree. This parse tree is then fed to the semantic analysis, which tries to find meaning in the program. Semantics defines the semantics in the program, and that is called the semantic analysis, where we get a semantically verified parse tree. And after that we get something, and it passes through the intermediate code generation phase that generates the target code, that generates the intermediate code, right? Intermediate code generation. Okay, let me write it properly. Intermediate code generation. After this, what it does is it goes through something called code optimization. Okay. And then finally it goes to target code generation. Right? So the phases that are labeled light blue or green, whatever you call, is forming your front end of the compiler, which takes the source code and converts it into something called an intermediate code. And these two steps over here form your backend of the compiler. Backend of the compiler, which is after the intermediate code has been generated, the code optimizations and generating the code for the particular target hardware is done by the backend. So again, why do we need an intermediate code? So let's say there was a C++ code as well, right? So what happens is it goes into something called preprocessor. It has its own set of front end, right? But in the front end, you can see that it generates intermediate code that is independent of it being a C or C++ code, and so it directly goes into the backend of the compiler system, and so backend is independent of the source language. So see, if you see statement 3 is incorrect. Statement 1 is the front end includes phases that are independent of the target hardware. Absolutely. So that is dependent on the source language, not on the target hardware. Statement 2 is the backend includes phases that are specific to the target hardware. That is also correct because if you look at the target code generation phase, it includes that phase that is specific to the target hardware. So option S1 and S2 are true. Okay. Now we move on to the next question. Okay. Okay. Consider the CFG shown below. The CFG consists of an entry node, then it's B1, B2, B3, and B4, and then you exit from the exit node, right? So, which one of the following choices correctly lists the set of live variables at the exit point of each basic block? So, if you know, we are doing data flow analysis, right? And we associate a inset and outset just before and after the exit of each basic block. Okay. So, just an example, look at the first basic block B1. Okay. If I ask you, in order for you to execute this basic block B1, what variables do you need an access to? Okay. What variables do you need an access to? You might tell me that, Aditya, actually, I can see that I need variables M and N, right? If I don't give you the value of M and N, then you won't be able to execute this basic block, right? Because there will be an error here. What is M? What is N? It doesn't know. So here you might think that I need M and N, right? And after just execution of this basic block, what information are you sending to the next one? You're saying, hey, I have defined A, I have defined I have defined J, I have defined M, I have defined N. So these are the set of variables. Again, so what is live variable? A variable is said to be live, right? If you define that variable, let's say you defined A here. If you are using that A later on somewhere, then the variable is live, right? For example, if you look at B1, the A that you defined here, are you using it somewhere else? If you see in B2 you are not using, but in B4 you are using, right? In B3 you are redefining this A, so this A has no use, the one you defined in B1. But if you use this path, if you go to B2 and then B4, then you will have to redefine the A, right? So I hope you understood this. Okay. Now here when we are doing data flow analysis, right, you just have to look at, so liveness analysis is also called a backward data flow analysis. Okay, it's called a backward data flow analysis where we assume that just after the final basic block, which is B4, the out of it is empty, which is 5, and then we propagate the information up. And how do we propagate? See, so what we do is there's a particular equation. In of B1 is nothing but whatever is the out of B1, right, minus whatever you killed in B1 union whatever you generated in B1. See, so look at in of B4. So out of B4 is 5. What are you killing in B4? Right? You are, if you see, if the I was coming from up somewhere, from somewhere the I was coming, you are killing that definition of I by redefining I inside here, right? So you are killing I. Okay. Union. Okay. Union. What are you using? Generating means in this case, what are you using? So let me write this as using. Not, maybe that will cause some confusion. So this is called using. What variables are you using? If you look carefully, you are using A, right? So you are using A. And so this is nothing but A. So this is nothing but A. Okay. Okay. And one more thing you need to look at is, so out of B3 will be the union of the successors of in of bs. So who is the successor of b3? Successor of b3 is b4. So it is nothing but in of b4, which is a. Now tell me, if I want to calculate the in of b3, so out of b3 is a, right? Minus, you are killing a because you are defining a in the basic block b3, and you are not using anything, so it's 5. So in of b3 is 5. Okay, in of b3 is 5. Okay, so here we have done that. Out of b3 is also a, in of b3 is 5, sorry, so it's empty. Now we go to b2. To write it here now. So taking some time to load. 1 second. Yeah. So out of b2 is nothing but union of successor in of bs. So in of out of b2 successors are b3 and b4, right? So if you look here, out of b2 is the successor of in of b2 and b3 and b4. So this is nothing but a, right? And in of b2 is nothing but whatever is the out of b2 minus whatever you have killed in b2. Minus whatever you have killed in b2. If you look carefully, you have killed ij union whatever you have used in b2, that is also ing. Now what is this? See, this I you are redefining, this j you are redefining. So these are part of your kill sets. Now to redefine this I, you are using the previous value of I. To redefine j, you are using the previous value of j. Again, watch my words. To redefine I, you are using the previous value of I. To redefine j, you are using the previous value of j. That's why I and j you are also using, right? So this will be nothing but a I G. A I G. Okay. Okay. Fine. Now we move ahead. We move to out of B1. So out of B1 is nothing but in of B2, right? Successor is B2. Now in of B1 is nothing but whatever is the out of B1, which is A I J minus what are you trying to kill in that? You see that you are killing A I J and you are generating or you are using M and N. So see, over here you are killing I and J and A, you are redefining it. You are using M and N, right? So this is nothing but M comma N. Okay, see, you can see it's matching what we wrote in the first case, right? M and N. Okay, are we done yet? No, actually, what we have to do is we also need to satisfy some new conditions as well, right? So you will have to look at few things here also. So what happens here is so out of B3, right? If you look at out of B3, right? 1 second, guys. 1 second. Okay, okay. Okay, fine. So see the out of before. I'm just checking whether I've done all thing correctly or not, because writing it here and teaching is two things together. Okay. So if you look at maybe I should write the sets here. That will be better, right? Or else it's very difficult to understand. So the out of before, right, should be the in of B2 as well. Why? See, you are redefining. So, okay, let me explain it again. So let's look at the set and that will be better. You looked at out of B2, you are getting A, correct? If you look at the out of B2, you are getting A, right? But there is a package as well. See, there is a package as well. This is called a package. Oh, okay. The package is not given in the question, I guess. Okay, I think the package is given in the question. Okay. There is a package. See, the package is here. See, this is the package. So out of B4 is also the in of B2, right? So whatever was present in the out of B4, out of B4. So this is the second iteration. Hope I have space here. So out of B4, right? Because of that package, I will get the in of B2 as well. So this is nothing but AIJ. Okay, okay. Because of the package, that is the package, right? That's why. Now your things will change a bit. Okay, so your in of B4 will also change because your out of B4 changed, right? In of B4 is out of B4 AIJ minus whatever you killed here, which is I, union whatever you generated here, which is A, or used, which is A. So if you look here, you get A comma J. So you have to satisfy some constraints, some criterias. Okay, you can look at my lectures also. I've discussed that extensively, but here I'm explaining in very brief, right? So now this in of B4 has changed. So out of B3 will also change. Out of B3 becomes in of B4, right? And with this also, the in of B2, in of B3 will also change. We stop where it doesn't change anymore. So A comma J minus you killed A here because you wrote A equal to 20 union phi, which is nothing but J, right? And that will be propagated to the out of B2 new as well. Out of B2 is nothing but in of B3 and in union in of B4 as well. So out of B2 will become A comma J, right? A comma J. And the in of B2 is nothing but A comma J minus A minus I comma J. So A you are not redefining here. So I comma J union I comma J, which is nothing but AIJ. So is in of B2 changed? No. So when something is not changed, right? When something is not, oh, in of B2, in of B2 is unchanged, right? In of B2 is unchanged. So that is why you can say that you do not need to go further. So when something is unchanged, that means you are uh, from the previous iteration, then your yeah, then your solution is done. Okay. So for out of B1 is AIJ, it's the in of B2. Out of B2 is AJ. Out of B3 is AJ. And out of B4 is AIJ. So Aij, Aj, Aj, Aij. So what is there any option? Out Aij, Aj, Aj, Aij. Option D is the right answer. Okay, fine. Now look at this C code and its corresponding assembly code with a few operands U1 to U4, which is unknown. Some useful information as well as the semantics of each unique assembly is annotated as 9 comments in the code. The memory is byte addressable. So this is a C code on the left. The corresponding assembly code is on the right, correct? So R1 and R2 consist of 0 and 10, so which forms your initialization and the final condition, final value of the I loop. R3 and R4 contains the base address of A and B, right? So what you are doing is if you look at the C code, right, you guys can read the C code properly. So it goes from I equal to 0 to 10. When I and 0, when I is equal to 10, that time you stop. So when R1 is equal to R2, you stop. You go to end, right? You go to end. Then what you do is you load word R5, 0, R4. So R4 denotes the base address of array B. You are loading the 0th location of R4 into the register R5. Okay. And then if you see, you do BI into it, which is BI left shift 3, right? So R5, R5, and U1 will be what? U1 will be 3. Understood, right? U1 will be 3 because n left shift x is nothing but n into 2 to the power x. So BI BI into 8 is the same as writing B of I left shift 3. So shift left BI U1 will be 3. Okay. Then you store the word R5, which is BI into 8, into 0 of R3. So you're storing it into the base address of A. Okay. You're storing it into the base address of A. Okay. Okay. The question I didn't explain. The question is you have to find U1 to U4, what it is. It's unknown, you have to fill it out. Now, what you have to do is now you move to the next address. See, so integer is 4 bytes, right? And its memory is byte addressable. So you looked at one integer bi. Then you have to look at the next integer, so which is 4 bytes from here. So b0 takes 4 bytes. b1 will take the next 4 bytes. So you have to move the add 4 to R3 and also add 4 to R4, right, to move to the next address. So this is actually 4. This is also actually 4, right? Okay. And once you have done this, you add R1, so your I equal to 0, you are incrementing your I, right? R1 becomes 1 now. And then you again have to go to the point where you are checking if R1 and R2 are same or not. So U4 is nothing but L01. So U1 is 3, U2 is 4, U3 is also 4, and U4 is L01. So B is the right answer. Okay. Okay. We look into the final question for that was asked in the compiler design subject. Second. Yeah. Consider the syntax directed translation given by the following grammar and semantic rules. Here N, I, F, and B are non-terminals. N is a starting non-terminal and hash 0 and 1 accelerating over manipulated hash 0 and 1 respectively. X dot val denotes the synthesized attribute, a numeric value associated with non-terminal X dot I1, and F1 denotes the I1 and F1 denotes the occurrences of I and F on the right hand side of the partition respectively. For the tokens 0 and 1, 0 dot val is 0 and 1 dot val is 1. The value computed by the translation scheme for the input string this is what? Rounded up to 3 decimal places. So what you have to do is, the first thing that you always have to do is look at the grammar, look at the string, and draw the parse tree. Okay, that's the first step, always. So 1, 0, hash 0, 1, 1 is my input string. Okay, and you have to look at the grammar. So you start at n. Okay, you start at n, you go, you take the first. So let's look at the grammar. So n, you can only go this step, right? You can only replace n with this production. So I hash f. So I hash f. Okay. Now I, so you have generated the hash. Okay. Now you have to generate 1 0 and 0 1 1. So 1 0 and you are standing at I. So you have only one choice. You will do I1 B. So you will do I1 and B. So don't be confused again. So I1 is not a new symbol, same as I, it's just to differentiate between the two. Okay. So now you can write I as B, so I as B, and this B as 1, this B as 0. So if you see, I've generated 1 0 hash till now. Now looking at the right part, you have to generate your the other part of the string 0 1 1. So from F, if you look at the grammar, you can generate F and B. Oh, sorry, B and F. Stop. You can generate B and F, and this B will give me 0. Why I need 0? Because after the hash I need 0. Okay. Okay. And then over here at F you can again change it to B and F, right? This B gives me 1, right? This F gives me B, and this B gives me 1. So if you see, I have generated the parse tree corresponding to this string. Now what you have to do here is take your pen, okay? Start from here, from the root of the tree, and keep on going down. See, I'm keep on going down till the from left to right. Okay, that is called tracing the tree. Now, when I am gone till here, if you see, when I went up to B. B is a symbol, and you have to look at the semantic rule. It says B dot val is 1 dot val. So B dot val is 0. 1, sorry. 1 dot val is 1, right? Given in the question. So B dot val is 1 dot val, which is 1. Now you go up. Now I1, now you use this one, right? I derives B. So I dot val is B dot val. So I dot val is B dot val. So this is also 1. Then you went here. You don't use any rules here because you have to go to the right child as well. You come from here to here. So B dot val is 0 dot val 0. Now you are tracing all the children of this I in the second level. So now you look at the rule. So I gives I1B. How do you translate this? What is I dot val? What is 2 into I1 dot val plus B dot val? Okay. So what is 2 into I1 dot val? It's 2 plus B dot val is 0. So this is nothing but 2. Then you go up, you don't do anything. You go to this hash, you don't do anything. You come here, right? You go to F, go to B, 0, come up, then B dot val is 0 dot val. So this B here gets the value 0. This F, you don't do anything because you have to come to this F as well. You go up now, B dot val is 1 dot val. So this is 1. B dot val is 1 val, this is 1. You come here. So F derives, so F dot val is B dot val here as well. Now the parent F, that is the F derives BF that we did, we have to find the corresponding rule. Um, Wait a second. Hey, why? Just a second, guys. Okay, this is strange. Okay, maybe. So F dot val is B dot val. Now the F derives BF. So F dot val is nothing but half into B dot val plus F1 dot val. Half into half into plus, which is 1. Okay, is it correct? Half B dot val plus F1 dot val. Okay. Okay, wait a second. I think I did some mistake, some small mistake. So F from F to B, if I go, F dot val is half of B dot val. Okay, that is a mistake I did. This is 1 by 2 actually. And so this is 1 plus 1 by 2, which is 3 by 4. Okay. Then you go here. Again, it's the same thing. So half of B, which is here it's 0 by 4, which is by 8. And then finally you go up. N val is what? I have to check that. N dot val is I dot val plus F dot val. N dot val is I dot val plus F dot val. So 2 plus 3 by 8, which is 2.375. Okay, so that will be your answer to this question is nothing but 2.375. Now see one thing here, right? This question is over, but can you find out what is the meaning of this grammar? It's very easy if you see. If you see, this grammar is converting from binary to decimal, and the hash here denotes your decimal point. So 10 in binary is 2. 0.011 in binary is 0.375. So this as syntax related translation that was given is actually conversion of binary to decimal. They might ask you questions like this also. They'll give you a grammar and tell you what does the grammar do. Okay, so make sure you're aware of this. Okay, so I think we are done with this compiler design discussion of problem solving. Um, if you guys have any questions, feel free to like and share this video, comment down below any doubts you have. Subscribe to this channel, right, for more such videos, and all the best for the exam. Okay, all the best for the exam. And with this, I would like to end the class today. Thank you for listening.